Hey, it's Gio Zanecchia. It's March 30th, 2025, and we have version 2.0 of the Electric Alfa 1975 Alfa Spider 2000 Veloce, converted to electric. I've got Nissan Leaf batteries in the trunk and a Curtis inverter with an HP EVS motor up front. The cool thing about this is that this is called like a retrofit, I guess, because the power is essentially the same as the original gas engine, so about 120 horsepower, except the difference is with the electric motor you got the 120 foot-pounds of torque at 0 RPM. So that's put it in third gear and hit the gas, or put it in first gear and hit the gas. But as you might have seen from the videos that we just shot, this thing really can get up to speed. And that was the key component for it being insured as a modified vehicle, modified classic vehicle, is that can it maintain a reasonable specification, roadworthiness of the original car? The answer is yes. So if you want to come around this side, I'll give you a little tour. Yeah, why don't you stand over here and then I'll point to stuff in the engine bay. So like I said, this is a, I think it's a 75 horsepower, but it's got 119 foot-pounds of torque, something like that. HP, it's an AC 50 AC induction motor, and it runs off the 1238 Curtis controller. Very, very simple. Obviously you can see that we're melting our gauge wire that's well below the spec that we should have. But it's what I had on hand to at least get it going. Luckily, it looks like the high voltage lines are okay. Just a caveat, the contactor is off right now, the car is off, so high voltage up here is not on at all. But we still need to be careful, but I just wanted to point out the melting loom here. We just noticed that now. So not surprising that I need to upgrade the gauge of wire. This is a 4 gauge wire, I believe, welding wire. We need to step it up to something a little bit beefier, but maybe it's just for the AC lines because the HV lines seem to be okay for now. And at cruise, it looks like it only pulls about 100 amps, which is within spec for those wires. There's a chill plate here, coolant lines that run to a coolant pump. We're using the stock radiator here to pump coolant through to cool the inverter. The motor is not cooled, so it's just air cooled. But the nice thing too is we have, stock brake line booster with a vacuum pump if we need the assist, which seems to be working. And the best part is if I put some brake fluid in here, we should have actually a working clutch. So I should be able to shift gears while I'm driving, which would be totally cool. Just going around here, I'll take the camera real quick. I have a cut there for the contactor power, and if you want to watch all the other YouTube videos, there's more info on that on the build. This is version 2.0. We first got this car in 2013, and I got it on the road in I think 2016. So I'll open this door up for you, and I'll just go around the other side so I can point to things. Seats in here, the stock gear shift. I've got some rudimentary switches and gauges obviously going to be put in. All the stock gauges don't work, but the nice thing that we do have is everything is keyed. So the car will not turn on until I turn the switch. You hear that click? That was the contactor clicking on, and now our spyglass is active. And if I hit the accelerator pedal, the car would want to move. But you can also just key off and it would cut everything. The other thing I did is I put this emergency shut off switch for the high voltage, and you could just turn around and hit that if for some reason, say the accelerator pedal got stuck, the key off wasn't working, or something got shorted, just shut off high voltage. The lights work, so we have turn signals and all the lights that run off a 12-volt battery in the trunk here. So this is just a deep cycle battery, which is charged when the batteries are being charged from this maintainer. And you can also just kick off your circuit breaker here as another fail-safe for the 12-volt side. Got my trusty scooter in the back to get out of, get home if I need to. Coming around the back. So these are the 16 Nissan Leaf cells out of a 2011 Nissan Leaf. They were salvaged from crashed cars, I understand. I bought them back in, I guess, 2015. And they seem to have some decent capacity left. The nice thing about this setup is that these were the original way they were built, with the brackets and the bus bars, and also the voltage sense wires. So I was able to use kind of the stock bus bars and sense wires that were on the original batteries to make them in series. So it gives me 128 volts. But there's also a BMS here, 32S BMS, because each Nissan Leaf can actually has 4 cells in it, 2 in parallel, 2 in series, but you need to monitor those ones that are in series, and they act like your standard ternary lithium cells. So this BMS is giving us status of each individual cell, also balancing them. When I'm running the charger, which is right there, it's a Thunderstruck charger. It's a programmable charger. There's a control unit that's behind the driver's seat, which I programmed with a Telnet application for a target voltage of 128 and a charging current of 1.5 amps, which is very, very slow, but it means that I can charge it from the Tacoma bed inverter, 2011 Tacoma, which only goes up to 400 watts. But slow charging is good. 400 amp fuse there. That was a special fuse that I bought, so it would split the pack in half if we went over current. And then inside here is your contactor power, which is run by the key on. And whenever there's high voltage, except for these red and black wires, which I should tape with orange tape to denote their high voltage, everything's loomed in the orange loom. So always wear your gloves. Don't touch any high voltage without your gloves on. And normally I have these covered, you know, but I'm gonna try to waterproof the whole system here too, just for, you know, due diligence. But the nice thing is that you can basically, at this point, turn the key, drive the car, like we just did, up and down the street. Obviously you need to upgrade the wiring a little bit, but here is your charging plug right here, and you can just hook that up to an extension cord, either 3-prong or with a cheater. So in terms of range and everything, we're gonna find out. We're gonna see what it is, and you know, hopefully if we get 5 miles out of this machine, you know, that's good enough just to get to the parks and the beach and back. So thanks for watching, and thanks for the support.